Hello students, you are welcome back to the 5 important rules that guide integration. So in the previous video, we discussed 3 rules. Now we want to discuss the remaining 2 rules for us to understand better how to integrate functions. Now, in this video, we start with rule 4, which says multiplying the variable by a constant makes no difference to the form of the result, but we have to divide by the constant. Okay, let's look at that. Look at this example. You know, this example is exponential 3x minus 4 dx. Fine. Remember, by standard functions or standard rules rather, exponential x dx, if you integrate exponential x dx, is always what? Exponential x plus c. And remember that. That is what the standard form says. But in this case, we are having a linear function as the exponent of our exponential function. So it's not just x, it's a linear function. So what you just need to do without stressing yourself, I can show you how that can be basically derived, but that will be done when we get to integration by substitution. Let me just tell you outrightly how you're going to go about this without wasting your time. So when you see things like this, just look at the constant function, the constant factor of your exponent. The constant factor is what? Is 3. Now divide this function by that 3 and repeat exponential 3x minus 4 plus c. That solves the problem. It's as simple as that. You'll be wondering, yes, it's as simple as that. That's just that for that. Now, let's look at another example. It's as simple as that. Now, example, let's call this 7. Example 7. Integrate dx all over 2 minus x. Fine. Now, if you look at this function very well, it looks like dx all over x. Now, remember, which says that that will be log x base e plus c. It looks like it. Yeah. So the only difference between this and that is just that this one has a constant 2, and that's, you know, it's a linear expression. This one is it's also linear, but in degree 1, but you can see there is an additional constant there. This one lacks the constant factor there. So what you just need to do, without wasting your time, you come across stuff like this, is what is the coefficient of your x? Just like we did here, when our coefficient of x is 3, and we divide by 3 there. The constant coefficient of x here is what? Is minus 1. So just write minus. That's it. Just write minus log base e of 2 minus x plus c. That solves the problem. You can see how simple it is. You are wondering, am I sure this is correct? That is the answer. That's the answer. We can prove that. We can show them. But for the sake of your examination, which is going to be CBT and the like, wow, you will need to understand how fast you could solve this problem. You know. Now, example 8. One more problem here. Integrate the square root of 5x plus 3 dx. Yes. Don't forget, this is the same thing as 5x plus 3 raised to the half dx. Do you agree with me that that's the solution? Do you agree with me? Okay. Now, to solve this problem, don't stress yourself. I said, it's just like saying that integrate x raised to the half dx. And you know that if you are integrating x raised to the half dx, it will be x raised to the half plus 1 all over half plus 1 plus c. So, that is it. But this time around now, this one contains a linear expression. It has a constant 3, but the coefficient of the x variable here is what? Is 5. So take note of that. You first of all divide by 1 over 5. And you divide the expression by 5. You know it will be 1 over 5. The real expression is over 5. Then, having done that, this expression now, as if you are performing function of function, half plus 1, that's normal integration, then all over half plus 1. Oh, wow, how come? What? No. That's the way it should be done. You know, if we had gotten only x, all of these is x represented by x, it will be half raised per x raised per half, which I've just shown you that it will be x raised per half plus 1 over half plus 1. So, but because it has a linear form of problem of variable, so just pick the coefficient of your x there, use it to divide the whole expression, then 5x plus 3, write it, then now perform the normal natural integration, half plus 1, all over the whole of what you have here. So it will be what? It will be 1 over 5 into 5x plus 3, 3 all over 2, all over 3 all over 2. So, you know, it's like 1 over 5 divided by 3 over 2, that's times 2 over 3 of 5x plus 3 raised by 3 all over 2. So that will be what? If you find out, you're going to have what? Okay, so you have, I hope you are following. So that will be what? 2 all over 15, 2 all over 15, 2 all over 15 of 5x plus 3 raised by 3 all over 2. So that's the answer. It's as simple as that. So take note. Take note. Now let's go to the last rule. And that is rule 5. Let's go to the last rule. And that is rule 5. Rule 5. Where's rule 5? Rule 5 says the integral of a fraction whose numerator is the derivative of its denominator is the logarithm of the denominator. What an interesting statement. But I will explain to you. So let's look at, let's just look at an example to illustrate that. Example, do you call it 8 or what? Let's just call it something. Okay? Integrate 4x cubed minus 1 all over x raised to power 4 minus x plus 2 dx. Now, look at what this statement says. The integral of a fraction whose numerator is the derivative, that is, the numerator of that fraction is the derivative of its denominator. Is the logarithm of the denominator. Is it not confusing? It looks confusing, but it's not. Okay, let's look at this rational function. It's saying that if you are given a rational function to integrate, try the denominator of that rational function. Differentiate it. You get what I said now? Differentiate the denominator. If you differentiate the denominator and you get the answer you get is the numerator. That means the value for this integral function is going to be the logarithm of your denominator again. Okay, don't worry. I will explain. You will get it. You get it. I trust. My students are there. They are very, students are serious. They easily get my explanation. Let's look at it again. Now, the statement says that differentiate the denominator. Also, it's only applicable to rational functions that exist in form of numerator and denominator. Now, differentiate the denominator. Let's differentiate it. Differentiation now. Let's want to differentiate x raised to power 4 minus x plus 2. Let's try it. By differentiating, we have what? Let me write it clearly. By differentiating x raised to power 4 minus x plus 2, we have, let's check what we are going to have. We have 4 times 1, 4x, then 4 minus 1, then minus, when we differentiate x, you know x has a raised power 1. 1 times 1, 1. Then x, 1 minus 1. Then plus, you know 2 is a constant, 0. I hope you can still remember how you were taught differentiation. So we got 4x cubed minus 1 times x raised power 0 is 1 plus 0, of course. So that is what 4x cubed minus 1. I want you to understand it. That's why I'm splitting it that way. So you can see that when we differentiated the denominator, we accidentally get numerator. So our answer now is, don't have to stress ourselves again. Therefore, the answer is log of the denominator that we differentiated. X raised power 4 minus x plus 2 plus c. You have to have a c. That's all. I will give us one more example, but that is it. That is it. Let's try another example. Let's look at this. Integrate, let's say example 9. Let's call this 9. Integrate 3x squared all over s cubed plus 1 dx. Yeah. Let's differentiate the denominator. That is s cubed plus 1. Let's check. I want to differentiate it. 3 times 1 here, 3x. Subtract 1 from 3, 2. Then plus 1 is a constant. So anytime you differentiate a constant, it will be 0. So the result will be 3x squared. So that is when we differentiate this now, we get 3x squared. And 3x squared is the value we obtain on our numerator. Which means that means the answer is now what? Log exponential, that is exponential e, s cubed plus 1 plus c. So anytime, the conclusion is anytime you differentiate your denominator and the result you obtain is what you have on as your numerator, then the answer will be log of that denominator that you differentiated plus c. It's as simple as that. It's as simple as that. So with this, we have come to the end of 5 important rules of integration. So in our subsequent videos, we look deeper and deeper into more of problems that require special techniques of integration. So don't forget, click on the notification bell so that each time I upload a video, you'll be daily notified. Thank you.